Good morning, everyone. Welcome back. Hope you guys have a wonderful Easter break. So what we're going to learn today, writing the numbers in a standard form and writing numbers in a scientific notation. So the vocabulary that we need to know in this lesson, it's a scientific notation. So in this lesson, pretty much we're going to look at it. What is a scientific notation? How can we write a scientific notation? And what are the uses of scientific notation? So basically, if you look at a scientific notation, we always write a product of a factor of an integer and a power of a 10. So the factor must be greater than or equals to 1 and less than 10. So what does this mean? So whenever you write a scientific notation, this is your general form, and a times 10 to the power of n, or we can write a should be between 1 and 10. It cannot more than be 10. Gotta be remember that. And let's say, for example, I have this entire number. So what I'm going to do, since the first number has to be between 1 and 10, so my decimal has to come right up here. So the first number. So instead for that, I'm going to move my decimal to the left, which is 1, 2, 3, 4, 5, 6, 7, 8. So I'm moving 8 spaces, so I write it 10 to the 8th exponent. Now let's look into some examples to understand better these questions. How to write a standard form. Now this question is given in scientific notation. How do I know it? I see a 10 to the 4th exponent, and then also the decimal has, it's this number 5.34. The 5 is in between 1 and 10. So this is a scientific notation. Now we need to write it into a standard form. So the standard form means it has a whole number. So I'm going to write it down this one, 5, 3, 4. And then see, this 10 to the 4th exponent means I'm going to write it 1, 2, 3, 4 zeros. I'm multiplying with 10 to the 4. So since I'm multiplying with the 10,000, I can write it 5, 3, 4. I add 1, 2, 3, 4 zeros. Now once I add the 4 zeros, but now I need to move the decimal the 4 places. So the decimal right here, so I'm going to move the decimal. Let me change the color. So the decimal was right here. So now I move to decimal or decimal places because the exponent says 4. I need to move it the 4 decimal places to the right. So I'm going to move 1, 2, 3, 4. My decimal goes up here. So you can write the entire answer 5, 3, 4, 0, 0, 0.0, or if not, that's fine too. So this is the answer for that. It's a standard form. Now let's look into another similar example. So this is a 9.62, and then the exponent says the power says is 5. So I'm going to move this decimal in 5 places. So I'm going to move this one 1, 2, 3, 4, 5. So now the rest of the places, we're going to fill it with the zeros. So I'm going to go 0, 0, 0. So this is in a standard form 962 thousandths. That's it. In the last example, when the exponent is positive, we move it to the right. And when the exponent is negative, like in this example, we have to move it to the left. So I can write this one 3.27, but then my exponent is negative 3, so I need to move it to the left. So it's 1, 2, 3. So the decimal goes up here and fill the rest of the places with the zeros. So that becomes 0.00327. So I'm going to give you a little hint. If the exponent is positive exponent, move the decimal to the right. To right. And then that's the first one. If the exponent is negative, move the decimal to the left. Remember this? Then it's easy to answer. The reason behind the moving left to right, when you have a positive exponent, you're multiplying with the more than 10, so that obviously the decimal is going to move to the right. When you multiply with the negative exponent, basically you're dividing, so that's the reason it goes to the left. Now in this example, we have a number, and now we have to write it into scientific notation. So when you write it in a scientific notation, what we need to do is we move the decimal to the left so we can get the n exponent. So I'm going to write this number 3725123 Now I'm going to move the decimal to the left to write an exponent. So it's going to get 1, 2, 3, 4, 5, 6. So 6 decimal places I moved because I need this one as a between 0 and 10, or the 1 and 10. So I'm going to keep it this one down. So I'm going to get 3.725. You don't need to write the zeros, but I moved 10 decimal places. I'm going to write it 10 to the 6. So now this one in a standard form to a scientific notation. So whenever you see a 10 to the exponent, and that is a scientific notation. Now in this question, we have to write this number into a scientific notation. In order to write the scientific notation, you see this decimals before the number. So this decimal has to go this way in order to get a scientific notation. So we're going to move the decimal. I'm going to move it this one 1, 2, 3, 4. So 4 decimal places. The answer is going to be 3.16 times 10 to the negative 4 places. So the negative 4. So this is a scientific notation for this. In this question, refer to the table. Order the countries according to the amount of the money visitors spent in the United States from the greatest to the least. Greatest means the big number to the least. So the big numbers. First of all, when you find the big numbers, always look for the exponents. So I can see the 10 to the 7 and then 10 to the 7. In these two, now when I have the same exponents here, so I'm going to look at these numbers and then compare them and see which one is bigger. 1.06, 1.03. So obviously 1.06 is bigger than 1.03. So I can give, this is the first, this is second. Now let's compare the 10 to the 6. Let me change the color. So in these two, India and Mexico, they have 10 to the 6. But again, now I'm going to compare the numbers in front. This is 7.15 and India has 1.83. Obviously, the Mexico is bigger number because it's 7.15. And so I'm going to give you this one as the number 3. Mexico is number 3, and then this one is number 4. So if you order them in the order, so first one is the UK, United Kingdom. That's the order. And then next one is Canada. And then next one is Mexico. And finally the India. So we put them in the order, greatest to the least. So let's look into the last word problem right here. So if you could walk at the rate of 2 meters per second. So just imagine that you're walking 2 meters for every second. It would take 1.92 10 to the 8 seconds to walk to the moon. So is this more number is appropriate to report this time as 1.92 times 10 to the 8 seconds or 6.09 years? Explain your reasoning. So we can say the measure of 6.09 years is more appropriate because, you know, the number 1.92 10 to the 8 is very large. So choosing a large unit of measurement is more meaningful. So obviously writing 6.09 years is appropriate. We cannot say it's not wrong, but again, it's more meaningful writing the larger number. So in writing the scientific notation, it's always helpful. All right, thank you guys. So please complete the work that I attached to.